Integers. Integers. This is the situation that hurts so many of you on the final. This is the situation that hurt a lot of you on the first test that we did, figuratively speaking, hurting. So we're going to do a review on this because we're going to be solving for equations. We're starting a whole new concept unit, okay? Whole new concept unit, and I want to make sure that you guys understand the integer properties so we don't make any silly mistakes. So as we reviewed a little bit last year, and then also beginning of the school year, integer rules. For addition, we decide which of these two rules applies. Please stop tapping your pen, Chloe, your pencil. Rule number 1, if adding integers with the same signs, for example, if it's a positive number plus a positive number, or a negative number plus a negative number, what you're going to do is you are going to add the digits and keep that sign. So if we have 5 plus 19, it's just simply 5 plus 19 equals 24. And if we have negative 13 plus negative 7, salud, that's going to be negative 20. So it's taking the two numbers, adding them together, and keeping the sign. Rule number 2, if adding integers with different signs, positive, negative, or negative plus a positive, you are going to subtract the digits, and keep the sign of the larger digits. So you're taking the one with the higher absolute value, subtracting the one with the lower absolute value, and keeping the sign of the bigger digit. By digit, we mean integers without their positive or negative sign. So, for example, we have 23 plus negative 18. So I'm going to do this right here. This is what your work would look like on tonight's homework. 18 subtracted from 23, and that equals 5. Since 23 is a higher absolute value, and it's positive, that is going to be positive. Garrett? Okay. Then we also have negative 23 plus 18. So we're going to take 18 from 23. So 18 minus, or 23 minus 18 is equal to negative 5, because in that situation, 23 is a higher absolute value. Do you agree? For those of you unfamiliar with absolute value, or just know you heard it somewhere but can't remember what it was, it's how many spots away from the number 0 they are on the number line. All right. Independent together examples. We have 18 minus 5. Those are two different signs. So what I'm going to do is I'm going to not have a highlighter. I'm going to subtract 18 minus 5, which is 13. Beautiful. 13. And I know that that's a positive number because 18 is bigger than, or it has a higher absolute value than negative 5. I'm just going to go ahead and go down to number 3. We have negative 12 plus negative 11. Since those are both the same sign, Garrett? That's multiplication. That's on the back side of it. No, but I like that you're on the same page, though. Well, actually, you're on the back page, but you're on the right track of mind. Okay? I'm going to add these two together because they're the same sign. And it's going to be negative because I have a negative number, which is becoming more negative. So, of course, the solution is going to be negative, or the sum is going to be negative. Talking about negative attitudes, anger management, right? Negative attitudes, like middle schoolers. I hate blah, 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 blah. So many sentences start like that. Here we have two different signs. I'm going to take the smaller number from the bigger number and keep the sign of the bigger number. So I have 18 minus 3 is equal to 15. And since 18 is bigger or 18 has the digit is bigger than 3, I'm going to keep it positive. Be sure to write this stuff down. Now we have two different situations here. We have three different situations. We have a 3 plus negative 11 plus negative 5. So I'm just going to do the order of operations, which means whenever there's an addition, you just go left to right. I have 3 plus negative 11, which means that I need to take 3 from 11, and I have 8. Now, 11 is bigger than 3, and 11 is negative, so what's my 8? Positive or negative? Negative. Plus negative 5. Now I have the same signs. Shh. I have the same signs. So I'm just going to add those two numbers together because I'm just following the rules that I had above. Quiet. Webb, do you have a question? Stop talking when I turn my back. 13. And because it's a negative and a negative, it's negative 13. Nope. Yeah, you say that until you look at your test from chapter 4 and you realize, oh. And then you look at your final, oh. Subtraction. This is the same thing as addition at the end, but we have to notice something first. It says here, change the subtraction problem. Here's the first thing we do. Change the subtraction problem into an addition problem and change the second integer as well. So it's keep, change, change. Keep, change, change. When you change the subtraction sign to an addition sign, you must change the second integer to its opposite. So it's keep, change, change for subtraction. Keep, change, change. Keep, change, flip doesn't change. It doesn't rhyme either, but it's catchy. To be referring back to dividing fractions was keep, change, flip. Yeah, that's the action. That's right. The remix, the 307 remix. All right. The independent examples. So I'm going to keep, I'm going to change, and I'm going to change. Now, it's just like the addition property. Yes?
Can we just do keep and then change? Because why don't we don't really do
Now it's just addition. So we have the same sign, so we know that we're going to be adding 9 and 5 and having it negative.
Oh, it's negative. Sorry.
It's not negative. Negative or positive.
No, it's not.
From the page,
Just two negatives.
because we changed the sign to being from subtraction to positive. Then we changed. You with me? Then we have to change also the integer from being positive to negative, and that's what we did. That's the double change. Let's do it again. We keep, change, change. But we did something different in this class. That keep, change, change was this. Remember that? Negative, negative, positive. Okay, that was for subtracting a negative. So it's 14. It's 14 minus 5. A positive 9 because 14 is bigger. That digit is bigger than the 5 digit. Keep, change, change. 18 minus 3 is what? Now, should that be positive or negative? Negative, because 18 is negative. It has a larger absolute value. That's right. Now we have number 4. Keep, change, change. I have 25 plus 25 plus 7. It's going to be negative 32. Good. I like that sound of confidence from people in the audience. Yes. Thank you. Yes. Let's double check that. Yes. Huh. Multiplication and division. Shh. Quiet. Yes.
So with number 4, when we did this first, the first time we did this, the subtraction, wouldn't we have gotten like a completely different answer? Because we didn't like would we answer. Oh.
Got it? Okay. Multiplication and division share the same rules. They are, however, completely different than the rules of addition and subtraction. Yes. Whenever we multiply a positive integer by a positive integer, this is your last chance for you guys aren't sitting together anymore. Every time I turn around, you guys are yapping. Positive multiplied by positive is a positive. Negative times a negative is a positive. Thank you for reading. Negative times a positive is negative. Positive times a negative is negative. Now, there's a trick to this. Okay, there's a trick to this. I want you to add this in here. And put a star there. If the number of negative digits is odd, the product or quotient will be negative. And a product and a quotient, product is an answer to a multiplication problem. Quotient is the answer to a division problem. If the number of negative digits is odd, the product and quotient will be negative. No, my volunteer assistant coaches are telling me that they're not going to be there for the Lincoln Liberty game today. So you will notice that whenever there are odd number of negatives, for example, here is an even number of negatives. You don't have to circle these. You don't have to circle these. There's an even number there, and look, it's positive. There's a odd number of negative numbers here, and look, it's negative. Here's negative, negative, it's positive. But here's one that's negative. Just one negative, boom. All right?
Okay, so they're both negative. It's a positive. They're both positive. They're positive. But if one of them is negative, it's negative.
Is 1 an odd number? Yes, it is. That's why it's negative.
If they both have the same sound, it's going to be positive. I already knew that.
So we have the same, yes, but you're only limiting it to 2. Because look at number 4. There's 3 of them. We'll get there. Here's what I'd like you to do. I'm going to do the first one with you. 40. -6. Stop. -6 times -8. There are two negatives there. That's an even number. So we know it's going to be positives. And 6 times 8 is 48. I would like you all to do these, but stop after 8. Go. Huh? Yeah, Will said they're not going to be there. So this is what you should have. Yes, sir. Yes. There's 4 high school boys that helped me coach. Now let's look at this one, number 9. Hopefully you guys were able to do that quick because you should know how to multiply and divide. If n is a negative number, so that's going to apply to both of these. It's going to apply to this one and also 9. So that means that n is any negative number. Any negative number. So n can be -2, it can be -208, it can be -5,432,612. It's just any negative number. Okay? Any negative number. Yeah. Now it says here, the value of n is the value of n to the 93rd a positive or negative number. So what that means is, as far as exponents goes, that means it's n times n times n dot 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 n times n. That means that there are 93 n's here. Okay, there are 93 n's being multiplied together. Is that positive or is that negative? Yeah.
Okay, I think it's negative because since 93 is an odd number,
You are correct. It is negative because 93 is a negative number. And what you wrote down on your paper above what we're looking at right now on my screen, if it's an odd number of multipliers, it's going to be negative. Yes. But it's not multiplying a negative times a positive. Okay, now I see what you're saying. Yes. Well, it's going to be the more efficient way to do it would be what manager said. All right, this next one, circle the correct answer. If negative n, so n is still a negative number. If negative n is, negative n is A, always positive, B, always negative, or C, not enough information. Negative n, when n is a negative number. A, B, or C. This one should do. I want you to hold up 1 for A, 2 for B, 3 for C. Show me. What you think? Don't worry about what other people are doing. There's no punishment if you don't have this. The negative n. Okay, I see a lot of different responses. Let's see if this changes everything or anything. Just to let you know, that is what negative n is equal to, negative 1 times n. So, 1, 2, or 3? The correct answer is it's always positive. It's always positive. A.
I had 4. I didn't know. I was
Here's how. Here's how. Yep. It's always negative because, remember, this n here is always going to be a negative number. Ooh. There.
Oh, so it's like 2 negatives.
Yeah, 2 negatives. That's why it's always negative. Or sorry, always positive.